Hey folks, welcome back. This is Joel, and in this series we are talking about Aruba's SD-branch solution. Right? We have done quite a lot in the series, starting from bringing up the topology. We brought up the branch gateways. We brought up the VPNCs. We also did the underlay, routing, and we enabled the tunnel orchestration. Right? We enabled the whole orchestration workflow so that the IPsec tunnels are going to be formed between the branch gateways and the VPNCs. Right, so just to give a quick glimpse of our topology, this is the topology, right? We've gotten the branch gateway 1 up, we've gotten the VPNC 1 and the DC2 VPNC 1 as well, right? We can have a quick look at our Aruba Central over here, right? Actually, there were few views which were not really showing up in the last video because we had just done the lab. I can quickly show you that all of that are showing up now. So if I start from devices, you can see the 3 devices are up for me, right, which is good. This is expected. Coming to maybe let's have a look at our tunnels, right? So if you come down to network services, you can now see, you can click on tunnel over here, click on hubs, right? And you can see on each of the hubs, they're showing up. You can probably click on them and at the bottom, you can see the control connections, right? Which is good. You can also see the tunnels if you want, right? So you can click on tunnels. You can see the 2 tunnels which are showing up from this particular VPNC, right? The same is the case with the second VPNC as well, right? You can click on it and you can see all the details, right? You can also see the details about the spokes, right? Which is in our case, we have 1 branch, right? So you can see the spoke is here in the center. I can click on it and you see all the 4 tunnels, right? Because we have the branch, from the branch we have 2 transports and we have 2 VPNCs. So you're going to have 2 tunnels per transport, and that's how you have like 4 total tunnels and all of them are up. Perfect. So this is good. We can also quickly have a look at our topology, right? So for looking at the topology, always go to the sites. Let's probably click on the store and I can go to topology over here, right? And there you go, right? So we have the branch gateway, we have the 2 transports, right? One is we're just calling our MPLS transport as the AT&T and the other one as Verizon, and you can see both the VPNCs. You can at any point of time, click on any of the link and you can get information about that particular tunnel, right? All the IP addresses, the VLANs, all of that, right? So which is pretty handy over here. Perfect. So that's what we have done, right? In this video, what we will do is we'll explore, now that we have gotten the basics up and running, right? We have the tunnels, right, which is out there. Now the very next thing what we need is, we have the tunnels are basically the data plane, but what's the point of just having tunnels, right, if I can't route my traffic over these tunnels, right? So the next step is basically to make sure you see these subnets here on the left hand side and the right hand side. So you have at each of the sites we have these subnets. So the idea is to probably use some type of routing protocols, right? Either it can be connected routes or it can be BGP, right? So we'll use some kind of routing protocol to inject these routes into our gateway, right? And then from the gateway, we will redistribute those routes into the overlay protocol. Like we have already discussed, the overlay protocol is OAP over here in case of Aruba, right? We remember we had OMP in Cisco's sd-wan. Here it is OAP. So we will redistribute those routes into OAP, and that way, the routes are going to reach the other side. And once they reach the other side, we can further redistribute it back into whichever protocol you want, maybe OSPF, maybe BGP, maybe static routes, right? So that's what we will do predominantly. And then while we are doing that, we'll also explore some very interesting features around, maybe how do you create a route map, or how do you kind of do route aggregation, right? How do you prevent a particular site from being a transit AS, right? So things like that, some small interesting, tricks as well, right? But predominantly this video is suited, or is mainly from a perspective of how do we do the routing in the overlay, so that we can ultimately send traffic over these tunnels, right? Perfect. Let's get to it. Okay, so step number 1 would be, let me grab my pen. So you have these SVIs, right? We already have created the SVIs on the BG1, right? What we'll try to do is we'll inject these routes, right? These are connected routes. We'll try to advertise these routes into where? Into the overlay, right? So we have the overlay which is basically a OAP protocol. Remember, we spoke about this. Like for example, this is the branch gateway. It is forming a control channel with the Aruba Central, right? Similarly, you have the overlay formed with the VPNC1 and VPNC2 as well. This is like the centralized control plane, right, in case of SD branch. So all we have to do is send these routes onto the overlay so that it reaches this route orchestrator, which is there here in the middle, right, which resides inside Aruba Central, and then that guy can reflect those routes to the different sites, right, based on whatever policies we have configured. So that's the whole idea. For now, we'll just send these routes from they are right now connected routes. We'll send them to what? The overlay. That's the step number 1. So let's get to it. So we'll go to Aruba Central here, right, and let's go to the branch group. Perfect. We will go to devices and then go to config. Okay, let's make sure I have my SSH access working. Give me a second. Perfect. So I have SSH. Good. So because I can show you some of the commands later, right? So I have the SSH access, which is fine. Perfect. So we are on the devices config, right? We'll have to go to the we are already in the advanced mode, which is good, right? So let's go to the routing section, right? How do you realize you're in the advanced mode or the basic mode, right? We have seen the 2 different modes, but did you notice how do you figure that out? Whenever you see a tab here for the basic mode, it means that Aruba Central is telling you to go to basic mode. You have to click that button, right? So that's how you understand you're in the advanced mode. Right now we're in the advanced mode, but Aruba Central is telling me that if you want to go to basic mode, click on this button. That's the whole understanding behind the UI over here, right? Coming to routing, since we are now getting into the overlay routing, we have to come to the overlay section. Remember, we did underlay routing in the previous video. That's why we used this IP route section, but now we are doing the overlay. That's why we are going to the overlay routing section, right? And here, let's come to this section called as redistribution routes. Right, not prefix list. You have different features over here, but we are interested in the redistributing routes, right? And let's click on plus, and here you can see you have different ways to redistribute. In our case, we are going to redistribute the connected routes because that's the SVIs which are present, right? So connected routes, and here in the filter we can select the VLANs. So I'm going to select 5, 6, where is 7? Okay, 5, 6, 7, and 8. Right, so there you go, 5, 6, 7, 8. Those are the 4 VLANs which we are going to select, and I think that should be it. We are going to hit the save button. Okay, so now ideally what should happen as soon as you did this, right? What should happen is the routes from here should come in. I mean, they are already on the BG gateway, but they are going to be now advertised into the control plane, right, using the OAP protocol, and it will go all the way to the Aruba Central. And by default, Aruba Central will reflect those routes, right, to the other sites, right? Aruba Central is going to tell VPNC1, hey, if you want to reach this particular subnet, which is pertaining to VLAN 5, you have to go to branch gateway 1, right? That's how the routes are going to be advertised through the overlay to the other. The routes are first going to go to the Aruba Central, right, and that route orchestrator will send these routes just like how you would do a BGP reflection, right? BGP route reflector, their routes are going to be sent to all the sites, all the other remote sites. In this case, we have 2 remote sites, right? So ideally, we should be able to see this. So let's go into, so we did the route redistribution on the branch. So let's come to the VPNC1 and see if we see the routes, right? So if I do show IP route, and let's do OAP, because OAP is the protocol. Like I said, it's like the OMP, right? So OAP is the protocol, which is the overlay protocol, right? So I'm going to be like, hey, tell me what are the routes which are learned via the overlay. And there you go. So we have 10.5, 100.5, 100.6, 7, and 8. Perfect. So we have all the 4 routes, and observe the admin distance and the cost or the metric for this particular protocol, right? This protocol is called as BC protocol. As you see here, it's a cloud overlay protocol. Happy? This is what we set out to do. Perfect. We can also double check on maybe VPNC2, and here also show IP route OAP. There you go. All the 4 routes are visible as expected. Perfect. We can also, I think, we can also, I mean, this is show IP route all. We can also probably run another CLI, which is show IP, I think it's OAP route all, I guess, right? So there you go. The 4 routes are visible here as well, slightly in a different format, and obviously some little more information as you see here, but that's another CLI which you can use to see the OAP routes. Okay. Let's also see on the branch gateway, right? So the branch gateway is the guy who is advertising these routes, right? So let's see what it is advertising. So you can use show IP OAP advertise, and there you go. You can see the VLAN 5678 routes, the connected routes, they are getting advertised. Okay. Maybe similar command you can do show IP OAP route, and there you go, right? So you can, yeah, these are basically some quick troubleshooting commands for you to check, is the overlay really learning the routes which I am kind of sending. And remember, we already checked this command just to make sure that your control plane is working fine. And when I say control plane, I mean from the edge device to the Aruba central, right? That control channel towards the route orchestrator, is that working fine? For that you have to do show IP OAP, and there you go. You can see it is connected, things are up, which means that when you are advertising some route into the overlay, it is correctly going into the Aruba central, right? That's the understanding of this. You can also see the numbers here. You can see the routes which were addressed is 4, right? Tunnels 4, so that's an important number, which is good. Okay, now so that's good. Now let's come to the second task for us, which is we obviously used this thing, connected routes here, right? But on the VPNC side, right, on both the VPNCs, we'll try to use BGP. That's why you see the AS numbers here. So if you observe the AS number, we are trying to do eBGP here, right? This is eBGP. This is going to be eBGP because you see the AS number is 65,002, whereas here is 4 and 5. We will also try to do, this will be iBGP between these two guys. You might think, oh, there is no direct link between them. How are we going to do, BGP, right? So what I've done is this particular link, which you see 0, this is a trunk link, right? So because it's a trunk link, now over one particular VLAN, I'm going to form one BGP like this, and over the other VLAN, I'm going to form another BGP like this. So that's why this is just a L2 switch. We will have actually technically 2 BGP neighbors, which is going to be, one is this one, right? Which is a iBGP, and then we'll also have one more BGP like this with this guy, which is a eBGP. Why? Because 65,000, 65,001. So we are going to learn, we are going to have a flavor of everything, right? iBGP and eBGP. So here it is going to be just eBGP. So you can see 65,022. So we are going to have eBGP here, eBGP with this guy, and eBGP here, right? So yeah, that's what we are trying to do. We'll try to do eBGP, basically eBGP and iBGP, right? And then in the next section, we'll try to advertise the routes. The BGP routes, will need to be, once we have the BGP routes on this DC VPN, the VPNC devices, similarly, we'll have to take those BGP routes and advertise it into the overlay, which we just now spoke of, right? The control plane. We'll have to advertise there because then those routes can be learned on the remote side. Perfect. So let's do this step by step so that we don't get confused. Let's clear that. Okay. So let me just hide my pen. Okay. So let's go to Aruba Central. So we will do this configuration at the device level, right? So we'll come to VPNC1, the DC1 VPNC devices. Let's click on the list button so that we can go to this particular device, and from here let's go to device, and again routing, and we are in the advanced mode, right? By now you understand what is advanced mode. So we are in the routing. There's a section for BGP here, right? So so we are in the BGP because we are configuring BGP, right? Remember in the branch gateway we did not have to do this step because we were playing around with the connected routes. You don't have to do anything with the connected routes. They're already connected. They're already present. But we are doing we are basically working with BGP now. So you have to explicitly configure BGP, right? BGP process, the BGP neighbors, and all of that on the device, right? and only after that, the routes can be advertised into the overlay, right? So BGP, so we're in the BGP section. What do we do here? So here, let's start with the enable BGP. Perfect. Let's extended AS format is good. What's the AS number which we used in the topology? It was 65,002, right? So we'll use 65,002. Perfect. The router ID is going to be the loopback IP, right? So I think we have used we'll use loopback. So we have a loopback 1180.100, so we're going to use that. So now let's scroll down, right? There should be a route map over here. Looks like I have to save this. So let's first save this and then put the route map. Okay, so we are coming to the route map section, right? So in the route map, technically you can define, what kind of prefixes or any kind of route maps, right? I mean, the whole point of route map is if you want to tinker with some BGP path attributes for a particular neighbor, you want to you want to filter out certain prefixes inside, outside, all of that you can do. In our case, we'll keep it simple. I just want to show you that you can create route map. So I'm going to just click on plus button here. It's going to give you this. So let's put a name as allow all, right? So I want to permit everything. Okay. Sequence number can be something like 10. I'm going to say permit, and we are going to hit the save button. So everything will be permitted, right? So that's a route map which I created, but technically, as you see here, there are a lot of things which you can do with route maps. And now we'll have to create the neighbor. So let's go to the neighbor section. So you see there's a neighbor section here. So all we have to do is go on adding the neighbors, right? So add plus sign and start by putting a neighbor IP address. So let's start with which are the 4 neighbors for us. If you see here, from this guy we have 1, 2, and 3 eBGP neighbors and 1 iBGP neighbor, right? So it will be 10.151.1, 10.131.1, and I think towards the core, if I'm not wrong, let's go back and check what's the IP on the DC1 core right over here. Let me disconnect this, one sec. Okay, show IP interface brief. So you can see it is, I believe it is towards the core, it is 10.1, this is the VLAN which I'm using to peer. So it will be 10.1.80.1, right? And the other guy will be, I think there is one more switch, right? If I'm not wrong, on the DC side, which is DC1 dash switch. Do I have a console for that? Okay, here, DC1 dash switch, right? Let's look at the IP address on this one. So it is 10.172.2, right? So these are the IPs with which we are going to now form the BGP, right? So let's start with the first one, maybe 10.1.81.1, right? The remote AS was 65,001, I believe. Yes, that's correct. And the route map which we just now created, right? I'm going to say allow all, right? Both inside and outside I'm going to allow all. So all the routes will be advertised outside as well as they will be imported inside. We're not putting any kind of restrictions as of now. So hit the save button. Similarly, we'll have to add the rest of the neighbors, right? So let's do that. There we go. Hit the plus button again. The second neighbor would be the switch, right? 72.2. Remote AS is 65,002. Allow all and hit the save button. The next one is 10. Let's hit the plus button, right? So it's going to be towards the internet. This is right, the internet router. The remote AS is, I believe, 65,004, and we will hit the allow button and hit the save button. And the last guy is the MPLS router, right? So we will do the same thing over there. So here again, the remote AS is going to be this guy. Hit the allow. Perfect, right? So we have added all the 4 neighbors which we intended to add, and I also showed you how you can attach route map to each of the neighbors. Perfect. Let me just quickly verify if all of this is good. 80.1, 65,001, 72.2, we've got 51.1, and the last one is 80.1. Perfect. So we've got all the neighbors configured. Now let's do the same thing on the second guy, which is the DC2. So let's go to DC2. Meanwhile, I think our neighborship should start coming up. So if I look at any of these devices, right, if you see DC1 switch, you can see the neighborship is coming up. And if I look at DC1 core, you can see the neighborship is coming up, right? So similarly, all the neighborships are coming up, because as and when you configure on Central, it is pushing the configurations onto the box, right? So, okay, so we are on the second device, which is the second VPNC. And on this guy, let's again go to, at the device level, click on device. And let's go to routing, let's go to BGP. Okay, the steps are very simple. Again, click on enable BGP, right? And we will also put the AS number here, which is from the topology, I think it is 65,022. Perfect. Router ID will be the loopback, which I think is 1280 dot this thing. So I'm gonna hit the save button. Right, the next is creating we'll have to go to the route map section here. Let's go to the route map section, right? We'll have to create the same route map which we created earlier, plus put the sequence and hit the save button. And let's do the neighborships, right? So the neighborships are you're gonna have 3 eBGP neighborships: towards the core, towards the internet, towards MPLS. So go top, click on neighbors, plus, and here it is 10 to 80.1. Remote AS is this guy, and I'm gonna allow everything. Let's do the internet next. The remote AS, right, allow all, hit the save button. And the last guy, $65,024, and save. Perfect. So we've got all the neighborships in, right? So we can start looking at, maybe let's come on to the CLI and check the configurations, right? So let's look at, let me clear the screen a bit. So if I do show run, I think begin BGP, and there you go, right? So we have the BGP configuration which we just now pushed on the VPNC1. Perfect. We can also check out the neighborships now, right? So we can do show IP BGP neighbors, and you can see the BGP neighbors are in established state, which is a good sign, right? I've already obviously configured BGP on my switches, right? So if you can see here, so run section BGP. So you can see there's a minimal BGP configuration on these devices. As a result, you can, and I think the only thing I've advertised in them are the loopback. So I've created loopback in this subnet 192.168.1.x subnet, right? Sorry, it's a /32. So I've created loopback on all the devices. Which devices? I've actually created them on, let's see, one sec. Yeah, so I've created loopbacks on all the devices 1, 2, 3, 4, 5, 6, 7, right? So all the devices have created loopback, and I've advertised them into BGP. So that's why you will see all this 172.16 IP addresses showing up in BGP, right? So yeah, that's I've already configured. But coming back to our VPNC, you can see all the subnets are good, right? So which is we can see all the neighborships are established, which is a good sign, right? We can actually go down and see rest of the neighbors. You can see all of them are in the established state. Now let's look at the routes. Show IP route BGP, right? There you go. So this is what I meant, 172.16 You can see 172.16 1.1, 1.2, 1.3. Then for the second site, it is it is going to be 2.1 and 2.2 and so on, right? So the second site, how are you learning the BGP? How are you learning the routes from the second site? Because we have a direct connectivity. Like, think of this as a DC network, right? DCN connectivity. So we have a DCN connectivity between the two sites. So as a result, there is BGP here as well. So the routes from this site are getting learned on DC1 through this connectivity, and that's why you see things with 172.16.2. All of these are coming from the second site. But anyway, on my VPNC now I have all the BGP routes. At least that's something which we can understand, right? You can also see information like, for example, from the B, you can understand it's a BGP route, right? It's somewhere mentioned here on the top, right? B is for BGP, and E stands for, you can see E over here stands for exterior. You can see I over here, that stands for interior, IBGP. Okay. All right. Let's also check on the second VPNC. So on this guy, if I do show run begin and BGP, you can see the BGP showing up. Perfect. Similar commands we can do: show IP BGP neighbors. You can see the 3 neighbors should show up, and all of them are in the established state. And yeah, we can also probably look at the routes: show IP route BGP, and you can see the routes are learned again from its own site as well as the DC1 site. Perfect. So what we learned till now, we figured out how to how to advertise the connected routes into the overlay. We learned how to just enable BGP, right, at the VPNCs. Now the next thing is we need to figure out how do we kind of so all these routes which this guy is learning, right? Like, for example, here it is learning all these routes. How do we take these routes from BGP and advertise it into the overlay so that our branch gateway will have these routes? Right now it will not have. If I go to branch and if I just run the command show IP route, you see here it doesn't have those routes, especially which routes I'm talking about. Like, for example, these guys, right? 10.1, 10.1, the 128, 129, 130, all of those are not showing up now, right? But once we advertise these BGP routes into overlay, they will show up. So let's do that. Okay, so mainly the subnets which we are going to concentrate are these ones, right? 10.1.1, 128, 129, 30 and 31. So for doing that, let's again go to VPNC1. Let's go to VPNC1 and let's go to devices, config. We are in the advanced tab. Great. Go back to routing and overlay, right? Anytime you are doing something with the overlay, you need to go to the overlay tab, right? Now in the overlay tab, what we'll do is we'll go to the redistribution routes, and we are going to, earlier remember we redistributed the connected routes. This time we will have to redistribute the BGP routes, right? So all you have to do is that, hit the save button. Okay. We also have to do the reverse, correct? Because the routes which are getting learned from the overlay, we'll need to redistribute that back to BGP, right? So otherwise you will not have full connectivity, correct? Like, for example, the routes which the 5, 6, 7, 8, right? The routes which are coming from this side, once it comes on VPNC, right, via the overlay, they need to be redistributed into the other way around. So let's do that. So for that, you will have to go to BGP, and let's create the rule number. I think you'll probably find it somewhere. Redistribute section, right? So redistribute section here, and then let's go and create the rules. Rule 1. So the rule 1 is going to be sd-wan overlay. That's what we want to advertise. And the second rule, we'll also have to put one more second. Let's actually hit the save button. Let's also advertise the connected routes into BGP, right? Let's do that, because the connected routes which are there can be advertised into the BGP, so that those routes the rest of the peers will learn, right? When I say peers, I mean guys like DC1 switch or DC1 core switch. Right now they would have not learned, right? For example, show IP route, right? You see here it doesn't we haven't learned the 128 and 129 and 130, right? But once we do this, it should learn. So what we'll do is we'll also redistribute the connected routes into BGP. This is just a way of saying that, you know, we are advertising these routes into BGP. That's it. Okay. So we have done that, which is a good thing. We'll have to repeat the same steps for our second VPC. So we'll come to VPC DC2. Devices, we are in the config. Let's go to routing, and in routing, let's go to overlay routing, right? In the overlay routing, let's click on, so here remember we have these two routes, which is 10 to 64 and 65. So we will have to go to redistributed routes, right? And here let's click on the protocol, and we're going to say BGP, right? Hit the save button. We'll also have to do the reverse redistribution. So for that, we'll have to go into BGP and redistribute section, and we'll have to enable sd-wan overlay, hit the save, and we'll also have to do the connected, hit the save button. Perfect, right? Let's wait for a few seconds for all of these changes to go into our boxes. Okay, so now let's start checking some of these things, whatever we did till now, right? We are mainly going to do the verification now. So we will go to global, right? Let's go to global. Let's go to network services, right? And this is the place where we can see so you see there is a two sections here. We already saw the tunnel orchestrator earlier in the previous video. Now we are going to look at the route section. And the route section, you can see there is a branch here, right, showing up. All we gotta do is, where's the branch? I think it's somewhere here. Click on it, and here there should be routes, right? And you can see 5, 6, 7, 8. So these are the routes which our route orchestrator has learned from our spoke, or which is the branch, the 5, 6, 7, 8. Make sense? Okay, so here you can see the routes learned by orchestrator is 4, right? Which is great. Similarly, we can actually go to maybe the CLI, right? Go to branch, and here we could do something like show IP route or show IP OAP route, right? And here you should basically see all the routes which we have started to learn, right? So you can see clearly here, the routes. Yeah, there you go. The 128, 129, 130. Remember those routes? Remember the 10 to 64, 10 to 65, right? They are getting learned from where? From the remote sites now, which is a good thing, correct? So that's a good thing. Perfect. Now let's probably also do a ping and see if we have connectivity. So what we are trying to ping here. So since now we know that we are seeing the routes from VPNC 1 and 2 on our branch, we can do a ping to say 10.1.128.1, right? That's the, let's check, I've forgotten. So on the VPNC, if I do show IP interface brief, these routes are actually coming from DC1 core, right? So from here. So let's check on this guy, show IP interface brief. Yeah. So 10.1.128.1, which is this guy. So we have an SUI on this guy, right? And I'm trying to ping this guy from the branch, from the other side. So now technically when you're trying to ping, what should happen? Traffic should go via the tunnels. That's what we just now saw, right? If you look at the branch, there's the branch here. If you see the branch here, it's clearly telling that to reach, for example, 10 dot, where's the 10 dot? Thing here, 10.1 dot, right? To reach that, you have to, it is preferring this one, right? So this is how it has to go, right? And it is preferring, what is it preferring? Let's check. Give me a second. Okay, no worries. I just got confused with the MAC addresses, but maybe let me just quickly show you what I mean, right? So like for example, when you look at a route 10.1.128.0, and when you look at this is the next stop for that, right? Or at the same time, if you look at the tunnel as well over here, you can see the tunnel, this particular tunnel is going to be obviously preferred, right? In fact, these two are equal cost, right? So this particular tunnel and this particular tunnel. So how do you understand, is it really going to VPNC 1 or VPNC 2? What you can do is you can look at the MAC address over here in the middle, right? So you can see the MAC address which starts with 02 and ends with 34. It should be mostly VPNC 1. So you can see, you can go to global, click on devices, and you can see starts with 02, ends with 34. It's the VPNC 1. Why? Remember, in the previous video, we have made VPNC 1 as the preferred data center for when between VPNC 1 and VPNC 2. Right? So as a side effect of that, what is even happening is you see the routes which are learned from the second site, which is 10 to 64, 10 to 65. Even for those routes, you can see the overlay is advertising those routes with the metric of 10, right? For the ones which are getting learned from VPNC 1. So as a result, though the routes are actually, present over here. So you see, let me use my pen over here. So though the routes are here, technically, this branch gateway can reach this routes directly like this, right? Through this tunnel, and then it can reach it. But because of the preference, because we have made DC1 is more preferred than DC2, and these routes are going all the way here, what is happening is, the routes which are getting advertised from here and here, right? So the routes are getting advertised from both the places. But when they are advertised into the overlay, these guys are getting preferred because they are getting a metric of 10 and these guys are getting a metric of 20. So when they go to the other side, you can see branches preferring these routes. Though it is actually directly connected here, still the traffic for these guys will come like this. It will come through this tunnel, and from here, it will come in this direction, right? So that's the consequence of, I just wanted to tell you that that's the consequence of what we can change that. In fact, we'll change it after doing the ping test. But that's the consequence of making a particular DC as the primary and the secondary. Right, so if you have forgotten where we did that, let me just quickly show you. It should be on the branch gateway and devices and here, right? So we did the VPN overlay, right? And here at the bottom is that, I think it doesn't show up, is it? Once you have already configured. Maybe it's just a UI issue, I guess. Let's see at the group level. Do you think it will probably show at the group level? Oh yeah, there you go, right? So here bottom you see at the group level you can see the VPNC 1 is preferred than VPNC 2. Perfect. All right, let's go back to, sorry for the digression. Let's go back to what we were trying to do. We were trying to do a ping from, so you can do a ping from source, right? For example, we can do a ping from the VLAN SVI. So VLAN is, let's do source 5, right? Because we have the VLAN 5 on this box. And there you go, we're able to ping, right? If I do a packet capture, technically we'll not be able to see anything. It will be all IPsec, but we can still do it. Let me just pull it up one sec. Oh, I just realized it, since it is equal cost multipath, right? We'll have to do the capture on both the links, but nevertheless, we'll probably do a PCAP at a later point. But the idea is that right now the packets are actually going from branch gateway to DC1, right? When you're trying to ping, and it is using the IPsec tunnels, right? It's using IPsec tunnels and going to the other side. That's what we have designed, and that's what our topology, or that's what the routing table even tells us, right? Clearly, when you're trying to reach 10.1.128.0, you can see the next hop is clearly going to be, it's using this tunnels, and this is going to be the next hop, which is actually the VPNC 1. Perfect. So now let's try to solve that problem which we had earlier, right? So what's the problem? So if I look at the specific show IP route, and let's do include maybe 10.2 maybe .6. Let's try to do that. Okay, there you go, right? So if you see these two routes, what's happening, or maybe actually let's look at from here. I think it's much better, right? Here you go. So these are the routes I'm talking about, right? The 10.2.64, right? So it clearly has, it is using VPNC 1 as the primary and VPNC 2 as a secondary, right? And you can see the metric is 20 for the VPNC 2, for VPNC 1 metric is 10. So how do we solve this? There are different ways to solve it, but in our case what we'll do is we will use route aggregation, right? So what we'll do is for that subnet, let's go back here. we will so these two routes, right, which we have, these two routes, we will continue advertising these two routes as it is from here, but from when you're advertising it from here, let's aggregate them. Let's maybe aggregate them, right? That way, this becomes the route which is going from here becomes a it will be a aggregate route, right? So on the branch you will have this aggregate route as well as you will have the more specific routes. And you know how routing table works, right? Routing table always prefer the route which is more specific. So as a result, now BG gateway 1 will prefer this particular tunnel to reach these routes, and not, it will not go to VPNC1. So we'll use the aggregation concept here, or summarization concept here, to make sure that the routes are preferred as per our requirement. Okay, coming back, how do we do that, right? So to do that, we will have to go to, since we want to do the aggregation on VPNC1, right? We'll go there, click on devices, right? We are already in the config section, fine. Let's come to sd-wan overlay, routing, obviously. And routing sd-wan, the overlay routing. And okay, wait, I think the aggregation should be done on the VPN. Okay, so let's go to VPN, and here sd-wan overlay, and here you see there is a DC aggregate routes, right? So here we want to aggregate it. So technically, if I want to aggregate it, what would be the best, if I want to aggregate these two guys, right? I think it will be nothing but 10.2.64.0, but the subnet mask will be 255.254.0, correct? So that's going to be the aggregated mask. So let's use that and do it over here. So let's come here, let's click on the plus button, right? So let's use the 10.2.64.0 and let's use the mask, right? Hit the save button. Perfect. So we have aggregated it, which means now technically, if you compare, right, if you go back, let's come back. I don't know how quickly it does, but let's go and check. We have this for reference already, right? We already have the reference here that this was the case before. But now what we'll do is again show IP route, show IP OIP route. And you can see now for 10.2.64 it is preferring there you go. So this is the aggregated route, right? But for 10.2.64 and 10.2.65, now it is preferring the VPNC2 directly, right? The one ending with 4F. The one ending with 3.4 is the VPNC1. So this is the aggregate route. If these two routes fail, it will go through VPNC1. But that being said, we will now be able to, actually we have not done this ping, right? Let's try to do this ping. I think it is 10.2.64.1, I guess. Source it from 5, right? So now this ping went through, but this ping would actually be going directly to the VPNC2, and it's not going via the VPNC1, because we used the concept of aggregation to make sure that the branch gateway preferred the more specific routes which are coming from VPNC2. Okay, so the last thing we want to check here is also do something related to BGP communities, right? And one interesting use case here is, let's try to prevent, right? So let's try to prevent our VPNC from being a transit VPNC, right? What I mean by that, you know how eBGP works, right? So eBGP, in the sense, this is eBGP over here, and this is eBGP, right? So when eBGP, with eBGP, you don't have the concept of split horizon, which we have in iBGP, right? Which means the routes which are learned from here, they come on to this guy, right? And because of the eBGP neighborship, those routes are again advertised to the eBGP neighbor, right? This doesn't happen with iBGP, correct? But because of this, there is also a problem, right? Like for example, here, if I can show you the problem is generally, the main problem this can cause is, it can turn your device into a transit device, right? Why? Because, like for example, say there is a route here, A, right? And that route is learned here by this guy, right? And then the route is again advertised to this guy, right? So now DC1 and there might be a direct link between these guys as well, correct? Now there might be a direct link here, right? So this device might be learning this particular route A directly, as well as it might also be learning from another BGP peer, right? Now what if this link goes down? Then this DC1 MPLS will try to use this link to go to A, correct? So that makes this device as a transit device, right? So that can happen. By the way, in this topology, though you see a lot of links here, I've actually not configured most of them. Technically, what I've configured, I'm using the links which I'm using are obviously this link, obviously this one, right? So that we can form the BGP neighborship. So this link as well, and we also will have this link because I want to form BGP neighborship with the VPNC. The rest of the links, like for example this guy and these guys, and even this one, I'm not using them. I've just connected them because I was testing few things, but you can technically connect all those things and make this transit AS use case a little more complicated if you want. But in our case, what we'll do this is we'll just do something very simple, right? So we know that there is a eBGP neighborship here and there is a eBGP neighborship here. Right now, if you go on to this device, you will see basically the loopback of this one, because that would have learned like this. Let's go and check that if that is happening. And after doing this exercise, we will make sure that the loopback is not getting learned. That is the whole exercise what we are trying to do here. So let's go and check what's the loopback of our DC1 internet, right? So if I go to DC1 internet here, you can see the loopback is 172.16.1.1, right? And if I go to DC1 core, you can see it is getting learned here as 172.16.1.1. Why? Because of the whole logic which I just now told you, right? Because of eBGP. After putting this policy in place, what will happen is, what we'll do is we'll go on to the VPNC and we'll tell the VPNC not to, pass on the routes. We'll just tell, the VPNC will still learn the route, like the VPNC will know about 172.16.1.1, but it will not pass on here to the other peer. So on this device, you will not see the route, right? So that's what we are trying to do. So let's go back here. Okay. So we'll do this using this community, right? So there's a specific BGP community called no export. So we will use that for this. Okay. So coming to this guy, we'll go to VPNC here, right? We are on the VPNC 1, click on devices. Let's do this at the device level, right? So let's go to list, click on the device, and on the device, let's go to obviously device. Hope we are in the advanced mode already. We are in the advanced mode, right? So we'll go to routing, we'll go to the BGP. By the way, you also have RIP, OSPF and all of that which you can explore, right, when you have time. But we are on the BGP side, and here what we'll do is the route map. Where is the route map which we configured over here, right? So this route map. So we have a route map. Remember, we allowed everything. Now what we are going to do is we'll add a new route map. We'll say no transit, right? And the sequence number is 10 and permit, right? So that's the route map, but there should be a set value. So what we are going to do is we're going to set, and it will be no export. The community value option is going to be it's a well-known community. It should be no export, correct? So that's what we are going to do. Click on the save. So wherever this community value is going to be used towards whichever neighbor, right, towards that neighbor, we are not going to send the routes which we have learned from other neighbors. That's the whole idea, right? So this is what we have selected, and I think no export is selected, so we can go and hit the save. Okay, so we have that. Now we can go to the neighbors, right, and towards all the 3 eBGP neighbors, right, towards the 3, which are the eBGP, I think it is 1, 2 and the last one. Towards the eBGP neighbors, let's just change the route map, right? So we are going to change the incoming route map, right? So because the routes which are going to be learned, so I'm going to make this as no transit, so that the routes which are coming in, as soon as I put this community on that particular routes, right, they will not be sent out to any other neighbors. So I'm going to hit the save button there. Let's do the same thing on the rest of the neighbors. The rest of the, technically you don't have to do it on the IBGP, so we'll just do it on the eBGP guys. Like for example, this guy, there'll be no transit, hit the save button. And maybe one last one, which is the this guy, right? So I'm gonna do the no transit here and hit the save. Okay. So now once this has gone in, right? Let's wait for a few seconds for the configurations, everything to go and sync, and the BGP, you know, maybe the neighborships and all to refresh their tables. Technically, if you go to DC1 code over here, right? If I run a show IP route. Right, there you go. Okay, there you go, right? You no longer see 172.16.1.1 anymore. We used to see it over here before, correct? If I go scroll top, you can see 172.16.1.1, but now we don't see 172.16.1.1 because of the policy which we just now put in, right? So yeah, that was an important piece, right? So we did a lot around the routing piece. Just to recap what we did. We started off with obviously, you know, advertising the connected subnets onto the overlay from the branch, right? That's what we started off with, right? So we did, right? So these routes from the branch were advertised into the overlay, right? Then what we did was we figured how to configure BGP, right? BGP over here, we configured BGP neighbors, right? We did the same thing on here as well, right? All the neighbors. And once we configured BGP, we figured out how to take those BGP and advertise it into the overlay, right? Then we also had a very interesting case where this branch gateway, because DC1 is the preferred DC and DC2 is the second preferred DC, what's happening is the overlay, when it sends the routes to branch gateway, right, it will automatically use a better metric for the routes coming from DC1 when compared to DC2. So what we did, because of that, branch was actually using DC1 to reach these routes, which is not good. So what we did was we aggregated these two routes from the VPNC1. As a result, you know, branch gateway started selecting or using these routes or these paths, mainly this tunnel, right, towards the VPNC2. Okay. And the last what we also did was we explored how to kind of write a better route map, right, which will like in this case what we did was when the BGP neighborships are formed and routes are, you know, imported or received, right, when the BGP routes are learned, we are going to attach a no export, you know, kind of a community, so that those routes are not sent downstream to the other neighbors, right? By default this happens because of that's the default eBGP you know, rule or the eBGP behavior, but we used a route map to kind of go away from the default behavior. We also checked the connectivity from here to this subnet. We also checked it from this to this guy. So we made sure that all the subnets are reachable and connectivity is there over the overlay, right? So yeah, I think that was basically everything which I wanted to cover in this video, right? So we have done quite a lot again in the series, right from the introduction, bringing up the branch gateways, the VPNCs, bringing up the underlay, right, enabling the orchestration and creating those IPsec tunnels, and finally also going and you know, playing around with the routing in the overlay, right? So using BGP, static routes, connected routes, using route maps and all of that, right? So we are pretty good with this now. So in the next video, what we'll do is, you know, we'll start playing around with the data policies. So what we did today was very much in line with control policies, because we played around with the control plane in the overlay, right? In the next video, we'll play around with the data plane in the overlay by, you know, defining some traffic steering policies, right? So do come back for more content on SD branch. Have a good day. Bye-bye.